Okay, so let us talk about like the first thing about circles. O sea, we have already done this in class, but I just want like everybody to have it like very clear. We're gonna solve the problems that appear in the packet. O sea, we're gonna call this like basic definitions. So remember that a circle is a set of points that are equidistant to a fixed point called center. No, an equidistant means the same distance. O sea, the circle is made out of all of these points such that the distance from all of these like highlighted points to the center is the same. O sea, from any point in the circumference to the center, this distance is the same as this distance. That is the meaning of being a circle, no? Uh, that distance that is so important, we call it radius. So, like this length is the same for any point over the circumference. That is the idea of the circle. We introduce two new concepts. One is a chord. This one is a chord, like the segment that connects 2 points in the circumference. And now if I extend this chord indefinitely, o sea, like if I make it a line, then what I will have is a secant. So the only difference between a chord and a secant is that the chord is a segment and the secant is a line that can extend in both directions. So if a chord is a line that passes through 2 points, we call a tangent to the line that passes through only 1 point. So a tangent passes only through 1 point. Let us go over some facts. The first fact that I want us to review is that so if you have in a circle, if you have a circle and you have a triangle made out with two radii, o sea, radii is the plural of radius. What type of triangle is this triangle? This triangle is an isosceles triangle. What does that mean? O sea, that this radius and this radius measure the same because they are radii, no? So they have to measure the same. And so if these two sides measure the same, that means that these two angles also measure the same, no? That is the meaning of having an isosceles triangle. So that is the first fact. We're going to use it continuously. Now, this is not obvious, but this is very interesting. If you have a tangent line, so the tangent is only passing through 1 point of the circumference. The radius made to that point, the point of intersection, is perpendicular to the tangent. O sea, if you have a line and a radius, a tangent line and a radius, these two lines should have what is perpendicular? Perpendicular is having a 90-degree angle, no? A right angle. O sea, we will have a tangent if and only if I have a right angle made in the point of intersection and the radius. And now the third fact that it is also not obvious is that if I have two tangents that intersect outside of the circle, o sea, like this tangent and this tangent, and they intersect outside of the circle, then this distance and this distance measure the same. Like intersecting tangents are congruent. Like this and this measure the same. Okay, so with these three facts, we're gonna manage to solve all of the problems up to here. Okay? So let us do that. Okay, starting with this one. Show that BA is a tangent segment to the circle. How do you show that something is a tangent? O sea, like you can say like, oh, it is obvious because it is only intersecting in 1 point. But if you want to show it, o sea, like the way of arguing this is that you have to argue, o sea, this is a tangent only if this is a 90 angle degree. Now, this is a 90 angle degree. That means that this triangle, this purple triangle, is a right triangle. O sea, like that triangle is a right triangle. And how do I check if a triangle is a right triangle? Well, we need to do this thing of the converse of the Pythagoras theorem, no? O sea, I need to check what is 9.5 squared. O sea, remember that this is, C is my largest side. 9.5 times 9.5 is 90.25. Okay, and I also need to check what is 7.6 squared plus 7.7 squared. So I plug it into my calculator. And that is 117.05. O sea, because these two numbers are not the same. O sea, this is not a right triangle, not a right triangle. You know what I am doing? I am doing like checking if this is true. Because it is not true, it is not a right triangle. Actually, what type of triangle is it? It is an acute triangle, no? So this is not a tangent line, so this is not a tangent. Not a tangent. Okay, I'm gonna ask you to do this several times in the problem set, no? Okay. Now, if we assume that I have a tangent, I need to answer the following. O sea, I know, the problem is telling me that this is a tangent line. If this is a tangent line, that means that the tangent and the radius make a 90 angle degree. O sea, what type of triangle I have? I have a right triangle. What information are they giving me of the right triangle? Well, they are giving me that this side measures 6 and that the JO measures 10. O sea, this whole thing measures 10. So if I want to find the measurement of JT, I have a right triangle, I have two sides. How do I find the third side of a right triangle? Well, I need to use the very famous Pythagoras theorem. And remember that the hypotenuse is the length that it's opposite to the right angle. O sea, the hypotenuse is also the largest side. So I do 10 squared equals 6 squared plus x squared. This is just Pythagoras theorem, a hundo, 36 plus x squared. Subtracting the 36, that is 64 equal x squared. X equals 8. O sea, JT equals 8. Amazing. Again, because I know that this is a tangent line, that means that this is a 90-degree angle. If it is a 90-degree angle, I have a right triangle. And what information do I have of my right triangle? Well, I have that the angle TOJ, o sea, TOJ is this central angle. O sea, this one measures 60 and OT measures 6. So I have a side and an angle. What do I do when I have a side and an angle in a right triangle? I need to use the famous SOHCAHTOA. So if I stand here, this guy is an adjacent, and the side that I am trying to find is an opposite. It is not a hypotenuse. It is not a hypotenuse. Remember, the hypotenuse is in front of the 90 angle degree. It is an opposite because if I stand here, it is opposite to me. What relates adjacent and opposite is the tangent. So tangent of 60 equals opposite over adjacent. What do I do if my variable is below? I need to, it's above. I need to multiply it. So this is 6 tangent of 60. I grab my calculator and I just multiply 6 times tangent of 60. And that is 10.39. So in this case, pero they are asking me for JO. My mistake. It's okay. So instead of using a tangent, I should be using cosine, no? Because what relates adjacent and hypotenuse? The K in SOHCAHTOA, no? So cosine of 60 equals adjacent over hypotenuse. So now because my variable is below, I just need to do a flip. I put it into my calculator, and that is 12. Also, you can notice that this triangle is a 30, 60, 90. But you can always do it with SOHCAHTOA. Okay, for this problem, you need to notice that this line and this line are both tangents meeting outside of the circle. That means that this line and this line measure the same, so this is 8.2 as well. And now this line and this line are tangents meeting outside of the circle, so this measures 8.2, and they are meeting outside of this circle, so that is 8.2, and this one as well is 8.2, so PD measures 8.2. This one, I think that we have done it before, so remember that RC, if this measures 4.7, this one should also measure 4.7 because it is a tangent that intersects outside of the circle, so they should measure the same. And now if ZU measures 7.3, then this one should also measure 7.3. The whole thing, TU should measure 4.7 plus 7.3, which I hope it is 12. Amazing. Okay, so look, we have two tangent lines meeting outside of the circle. So we haven't even started, and what can we say? We can say that these two lines measure the same. So what information is the problem giving us? That this measures 36, APO. APO. This one measures 36. Okay, we also know that it is a tangent. So what can you tell me about this angle? This angle measures 90 degrees. And what are they asking me for? They are asking me for BOA. What is BOA? BOA. They want me to find the measurement of this angle. Okay, how do we do it? Well, I believe that you can see that here I have a right triangle that I'm going to put in purple. So because this is a right triangle, like the measurement of this angle is just 180 minus 90 minus 36. Because like in this triangle, I have a 90, I have a 36. So that one is just 180 minus 90 minus 36. That is 54. And now if I want to find this green angle, I need to do it times 2. So this is 54 plus 54, 108. Now, if they are telling me that AO measures 5, they are asking me to find PO. So in this purple triangle, I have a side and an angle. So I need to do, whenever I have a side and an angle, I need to do SOHCAHTOA. So I am trying to find which one is this. So if I stand here, this guy is my opposite, it's my up, and this guy is the hypotenuse, no? This one, because this one is in front of the 90-degree angle. So how do I find PO? I need to relate opposite and hypotenuse, so I need to use the saw. So sine of 36 equals opposite over hypotenuse. Because my variable is below, I need to flip. So 5 divided by the sine of 36 is 8.506. So how much does PO measures? PO measures 8.506. Okay, now this one is a little bit funnier. BC is a diameter. What type of triangles are BAD and BAE? what type of triangle it is? Well, because this thingy is a radius and this thingy is a radius, both of them are congruent, so that is an isosceles triangle. And because this is also a radius, both of them are isosceles triangle. Okay, so if these triangles are isosceles, what can we say? So the measurement of this small angle in here is 18 because it is isosceles, and the measurement of this little angle in here is 26. So how can I find, for example, angle BAD? Well, I know that inside of a triangle, angles add up to 180, so I just need to do, o sea, this angle in here is going to be 180 minus 18, which is 144. So this one is 144. Now, angle BAE, I find it in the same way. O sea, I just need to do 180 minus 26 minus 26. I am using my calculator. I am so sorry. This is 128. Now, if I want to find angle DAC, o sea, you need to observe that these two angles make a linear pair. So to find the AC, I just need to do 180 minus 144. Which is 36. Okay, and to find CAE, the same, like, observe that these two angles make a linear pair. So CAE is just 180 minus 128. Which is 52. Okay, and now to find angle DVE, I just need to add up these two angles. O sea, DVE is just 26 plus 18, which I have a feeling it is 44. And now to find angle DAE, I just need to add 36 plus 52, which is 88. And what relationship this angle and this angle like hold? Well, I can see that 44 is half 88. Which is interesting, no? O sea, like this angle is twice as this angle. That is a relation. Okay, problem number 7 completely is just doing the same as we did before. So I'm gonna skip it. You try to do it by yourselves. I'm gonna write the answers and you can check it. Problem number 8 as well. You need to check if this is a tangent. How do you check if this is a tangent? Well, you need to use the converse of the Pythagoras theorem. You need to check that actually this is a right triangle. I will write down the answers and you can check. But like try to do these problems by yourselves. Problem number 9, I think that it is a very interesting problem. This is a problem that I would love to ask because even though that it is a problem about circles, it is a problem also that has to do with solving equations and not solving any type of equations, but solving quadratic equations. So if I were to call this problem anything, I would call it a tough cookie. Okay, so look, this is a tangent. Because this is a tangent, what type of triangle is this triangle? This is a right triangle. So if that is a right triangle, I can do Pythagoras theorem. Okay, so I need to find my hypotenuse. What is my hypotenuse? This thingy is my hypotenuse. O sea, that is r plus, let me use another color. That is r plus 9. O sea, this thing in here is r plus 9. Okay, so I'm going to do r plus 9 squared equals my legs squared. O sea, that is r squared plus 15 squared. Okay, now if you think, let us solve this equation. If you think that this is r squared plus 81, kids, you are wrong. Like, what is r plus 9 squared? R plus 9 squared is r plus 9 times r plus 9. Okay, so you need to do some FOIL, no? So let us FOIL. So this is r squared plus 9r plus 9r plus 81 equals r squared plus, I believe, 125. Hopefully. Now observe, because I have r squared on both sides and I can cancel it out. So this becomes 18r plus 81 equals 125. I subtract. This is 225. Whoopsie doopsie. Whoopsie doopsie. 225. 225 minus 81, that is 144. O sea, 18r equals to 144. And divided by 18 equals 8. So r is 8. So the radius measures 8. Now, what is the measurement of AC? Well, AC is just 8 plus 9. 8 plus 9 is 17. And what is the measurement of angle VCA? If I am giving you two sides, how do you find an angle? Two sides of a right triangle. O sea, well, it depends on what are these two sides, no? O sea, if I am standing here, this guy is an opposite, and this guy is a hypotenuse, no? So what relates opposite and hypotenuse? Sine. But because I want to find the angle, instead of using sine, I'm going to use inverse sine. So inverse sine of a opposite 8 over hypotenuse 17. So you go to your calculator, shift sine 8 over 17, and that is 28.07. Amazing. So we're almost done with these problems. Okay, this is a beautiful problem that it's kind of like a puzzle. O sea, observe the following. So this tangent and this tangent measure the same, no? Because they are common tangents to a circle that they intersect. So this one measures 2. If the whole thing measures 6 and this part measures 2, that means that this line in here measures 4. If this one measures 4, this one measures 4 as well. If I go into the other direction, o sea, like if this whole thing measures 5 and this one measures 2, that means that this part measures 3, which means that this part also measures 3. And what did I want to find? The E, so the E measures 7. Okay, now this is a beautiful problem about a quadratic. O sea, see how I am just like embedding a quadratic in here, because these two are tangents that meet outside of the circle. That means that I have 2x squared plus 4 equals to 22. So this is not a hard quadratic. Because look what I can do. Like I can just subtract the 4, divide by 2, and what is the square root of 9? I have two options. I have 3 and negative 3. And both of them like can be plugged in. O sea, like we need to plug it in and check. O sea, for example, what is 2 times negative 3 squared plus 4? That is the same as, o sea, that is 2 times 9, 18. This is 22. And 2 times 3 squared, this is also 22. So both solutions work. Nice. Okay, the last two problems. If you see this, if I have a tangent, o sea, that means that this angle is a 90 degree, this angle is a 90 degree. What other angles are congruent? Well, this angle and this angle are vertically opposite, so that means that those two angles are congruent. And well, by angle, o sea, only by those two angles, by angle, triangle ARC is similar to triangle BSC. O sea, because they are similar, then they are proportional. So that means they are, o sea, they are similar, so they are proportional, no? They are similar, so sides are proportional, because that is exactly what this is saying, no? It is saying that AC over BC is the same as RC over SC. O sea, like doing the division of sides will give you a scale factor. Okay, and let us do the last problem of this section. I feel that this is a very tough, cute problem. O sea, they are telling us that QT, the QT, measures 6. TR measures 8. Okay, so we can do some Pythagoras theorem. Do you agree? We can do some Pythagoras theorem in here. O sea, we can find this side, that is the hypotenuse, so I just need to do 8 squared plus 6 squared, o sea, which is 64 plus 36, which is 100. O sea, that means that that side measures 10. O sea, this one measures 10. So look, you have a small triangle in here that it's like 6, 8, and 10. And then they are telling you that PR measures 30. O sea, if PR measures 30, observe that these two triangles, again by angle, o sea, this angle is the same as this one, both of them are 90 degrees, so they are similar by angle, and there is like a scale factor, o sea, I am multiplying by 3 to get this big angle, no? Because 10 times 3 is 30. O sea, that means that this side is going to measure 8 times 3, 24. And that this side is going to measure 6 times 3, 18. O sea, it is very clear that this one is going to measure 18. And now be careful, because this part won't measure 24. O sea, the whole thing measures 24. So this part only measures 16. O sea, because I am talking about like this red triangle is this triangle, no? O sea, like the whole thing. The whole thing. Okay, I really hope that you enjoyed it and keep watching.